Hello everyone. We're going to take the time to review some basic trigonometry. From last year's math class, you probably remember these SOH CAH and TOA to help you find the side length of or a missing angle from a right angle triangle. So I'm just going to rewrite the equations up here as the sine of an angle, theta, is equal to the opposite side of a specific angle divided by the hypotenuse. While cos stands for the cosine of an angle, and we can find the cosine by dividing the adjacent side length with the hypotenuse. And the last one, TOA, is the tangent of that angle theta, which is the opposite side length divided by the adjacent side length. Now, which applies to each one of these cases? So let's have a look at this first case where we have a right angle triangle. We know it's a right angle triangle because of this right square that's in the 90-degree angle. And we know that the opposite side of that right angle triangle is the hypotenuse. Now that's the first thing we should identify in a right angle triangle is the hypotenuse. If we're given this angle here and asked to find its opposite side length, this means that we're going to have to work with sine of theta. Okay, so I'm going to use so the sine of 42 degrees will be equal to the value I'm looking for, so the length of the opposite side, divided by the length of the hypotenuse, which in this case is 13. Algebraically, to solve this, I would multiply both sides of my equal sign by 13. So this gives me 13 times the sine of 42 degrees, and that would give me the opposite side length. When I do this math in my calculator, I should reach the answer 8.7 as the missing side length. In my second case, I'm looking for the opposite side to my angle, but I'm not given the hypotenuse, right? The hypotenuse is unknown. I'm given the adjacent side length here as 10. So adjacent and opposite can only be found using TOA. So the tan of my angle of 37 degrees will be equal to the value of my opposite side, which is the side I'm looking for, so I'll put an X here, divided by the length of my adjacent side of 10. So again, algebraically, all I'm going to do is multiply 10 on both sides of my equal sign. So I'm going to end up with 10 times the tan of 37 degrees. That will be my X. And when I punch these numbers in my calculator, I reach 7.5. Our last case here for finding a missing side length, I'm actually looking for the value of the hypotenuse. And I'm given this angle 41 and the side that's forming this angle, that is also known as the adjacent side. So for this one, I'm going to be using the cosine. Okay, so CA. So the cosine of 41 degrees will actually be equal to 13 divided by my hypotenuse, which is x. Now in this case, I need to multiply both sides by x to solve. So it would give me x times the cosine of 41 degrees is equal to 13, which doesn't quite isolate my variable x. So I'm going to need to divide both sides by the cosine of 41 degrees. And that, once I do the calculation of that, should give me the value of the length of the hypotenuse. So when I take in my calculator, I punch in 13 and I divide it by the cos of 41 degrees, I reach 17.2. Now, if I'm looking for missing angles, I'm going to use the same SOH CAH TOA, but a little differently, because now I'm going to need to find the value of the inverse of certain values. So again, let's identify what I have. I'm looking for this angle. I have the opposite side value here, okay, with a length of 5, and I have the adjacent side here. So I'm still going to use TOA, right, which is the tan of my missing angle theta, and I'm going to divide the opposite side length, which is 5, by the value 12. But that's only going to give me a decimal or a fraction. So in order to find the actual value of my angle theta, I need to do inverse tan, okay, which on your calculator will be represented by tan exponent -1. You potentially will have to press on shift first, or second function, or whatever your calculator gives you. So you're going to press that, and then you're going to use the result of your fraction, or you can put it into decimal if it's any easier, to find the value of the angle, which is 22.5 degrees, I believe. Okay, I may be off a little bit on my decimal value. So that's case number 1. Case number 2, I'm looking for this angle value. I have the adjacent side length, which is 4, and I have the hypotenuse. So I'm going to be using for this one the cosine, so CAH. Okay, so the cosine of theta will be the adjacent side, which is 4, over the hypotenuse length, which is 13. Again, I'm going to have to use the inverse of cosine, so exponent -1, and multiply it by the result of this fraction. And that should give me an angle of 72.1 degrees. Finally, in our last case, we're looking for this angle. We have the opposite side length, which has a value of 5, and the hypotenuse, which has a value of 10. So for that one, I'm going to use the sine, the SOH. Okay, so sine of theta will be equal to my opposite side length, which is 5, over my hypotenuse length, 10. Same principle as before. On my calculator, I'm going to be doing inverse sine and multiply it by the result of 5 divided by 10, which is 0.5, and that will give me a value of 30 degrees for my last angle. Hope this quick review has been helpful for you.